Okay, 6th grade, let's talk a little more about radicals. Okay, square roots. Let's follow this slide down. We want to approximate the square root of 7 to the nearest whole number. Well, let's think about that. Obviously, it's not a perfect square. We know that 3 squared is 9. We know that 2 squared is 4. So it has to lie somewhere between 2 and 4. So let's look at this. Identify the perfect squares on each side of the 7, 4 and 9. If we take the square root of everything, okay, the square root of 4 is 2, the square root of 9 is 3. So the square root of 7 has to be between 2 and 3. Is it closer to 2 or is it closer to 3? Well, we're going to try 2 and a half. 2 and a half, let me show you this on a number line. Here is the square root of 4, which is 2. Here's the square root of 9, which is 3. The square root of 2 and a half, or the square of 2 and a half, is 6.25. So the square root of 6.25 is 2 and a half. Well, that would mean that the square root of 7 has to lie in here. So it is closer to 3. Somewhere in here is the square root of 7. That is how you would round the square root of a number to the nearest whole number. Well, what if we wanted to go to the nearest tenth? I'm going to show you how to do it manually. We are not going to practice this. You need to know how to do it for the sake of standardized testing in general knowledge. Okay? Once you find that it's between 2 and a half and 3, then you're just going to try them all. You're going to try 2.5 and square it. You're going to try 2.6 and square it until you get the closest tenth. And that is how you would find it to the closest tenth. Like I said, we're not going to practice this. We're going to use our calculators to do that. You should all know how to use your square root key on your calculator. Obviously, we're not meeting these days, so you'll have to let me know if you have any trouble doing that. Let's look at a practical word problem. Okay. The maximum speed, which we're going to call s, in feet per second that an animal can walk is equal to 5.66 times the square root of the length of the animal's legs. Okay? This researcher found this out. What can I say? Let's start with our formula. We have a giraffe that has 7-foot legs. We're going to plug into the formula. Okay, L is the length of the legs. We plug in the 7. Take out your calculator and work that out with your calculator. Now, the best thing to do is to take the square root of 7, put in 7, take the square root of it in your calculator, and then multiply that by 5.66 before you do any rounding. And then you round at the end, and this comes out to about 15 feet per second. You can freeze the video at this point and try a few of these square roots. See if you can approximate them to the nearest whole number, and then use your calculator to do them to the nearest tenth. We go ahead and freeze that and try a couple. I'm going to put up the answers. And there are the answers. And I'll let you pause your screen and see if you worked those out correctly. Now we want to move on to, I know this is kind of a busy screen, to talk about real numbers, rational numbers, and irrational numbers. Well, what's a real number? A real number It's basically all the numbers you've worked with up until now in math. Okay, they can be shown on a number line. You can graph it on a number line. They include decimals, fractions. Pi is a real number. All numbers that you've worked with so far in math. So why are they called real? Well, there is something that's not real, and you'll get to that in Algebra 2. They're called imaginary. All real numbers are either rational or irrational. Let's look at this Venn diagram down here. This is a Venn diagram. This entire box represents all the real numbers. Well, it's divided into two parts that don't overlap. A real number is either irrational or rational. Let's look at rational first. The root word of rational is ratio. Ratio, we think of A over B. A rational number can be put in the form of A over B, where A and B are integers. Okay, if you can take a number and write it as A over B, where A and B are integers, then it is a rational number. If you can't, then it's irrational. Okay? Obviously, all fractions, all terminating decimals. Any decimal that terminates can be written as in fractional form. Any decimal that repeats can be written in rational form. That's an exercise we'll get into later. Irrational numbers cannot be written in the fractional form. That would include numbers like pi. It goes on forever in the decimal form, but it does not repeat. There's no section of it that will actually repeat again. It's random. The square root of anything that's not a perfect square is irrational. It will go on forever with no repeating pattern in those decimal places. So the square root of anything that's not a perfect square is irrational. You need to be able to identify a number as rational or irrational. Okay? You will need to be able to identify that a real number is either irrational or rational. Let me give you a few examples to try. Freeze your screen and think about these for a few minutes, and then I'm going to pop up the answers. Okay? The square root of 2. Well, the square root of 2 is irrational because 2 is not a perfect square. Okay, the square root of perfect squares are rational, but the square root of a non-perfect square are irrational. Negative 1/9 is rational because you can write it as negative 1 over 9, which is A over B, where A and B are integers. The square root of negative 169 is rational because the square root of 169 is 13, so we have negative 13, okay, which you can write as negative 13 over 1, so it is rational. This pattern here is irrational because it does not have a repeating pattern. Okay, it may have a pattern, but it's not a repeating pattern. So that is irrational. You can freeze your screen again and answer these questions. Tell whether each of these is rational or irrational, and you should have your handouts available to you if you looked at those. And there are the answers for those. The square root of 144 is 12. That's rational. It can be written as 12 over 1. Negative 11/7 is rational. It's negative 11 over 7. The square root of negative 46 is irrational. 46 is not a perfect square. And this repeating decimal does not have anything that repeats. Therefore, it is irrational. That's all I have for you today.